The next set of problems focus on a recent research study that measured diastolic blood pressure, DBP, of 1,020 clients in the study. They found that the mean DBP was 76.9 and the standard deviation for DBP was 6.2. If we define hypertension in this study to be those with the top 20% DBP, what would be the level of DBP that would begin the hypertension range? So we're taking a look at a normal distribution. We're looking at the top 20%. And the particular Z table that I'm using looks at all the probabilities up to a particular point. So I'm actually looking for, if this is the top 20%, I'm looking for the Z figure that corresponds to 0.80 to the left of this point. So I go to my table and I'm looking up, it's the table to the right of the mean, and I'm looking up 80% actually in the table. The closest number that we have is 0.84. This is 0.7995. So the Z value that corresponds to that number is 0.84. So I'm going to use a Z value of 0.84. That Z value is going to be put into the equation. Z equals the score minus the mean over the standard deviation. Since we know that this is 0.84 and the mean is 76.9 and the standard deviation is 6.2, we calculate this out and we find the score is 82.1. So that's the cutoff for the hypertension region. Then the second question is, considering the size of the sample, it's 1,020 in the sample, and the central limit theorem, the mean of the sampling distribution for this study should be what value? Well, the central limit theorem says that as the number of individuals in the study increase, that the mean for the sampling distribution should get closer and closer to the mean for the population. So our prediction is that this mean value will get closer and closer to the population mean, which is 76.9. Number 12 asks a different question. What happens to the sigma for the sampling distribution? Well, to do that, we have to use sigma x bar equals the standard deviation divided by the square root of n. How many people are in the study? So it's 6.2 over the square root of 1,020, which turns out to be 0.194.